Hello everyone, I'm Yuanxin from National Engineering Laboratory for Educational Big Data, CCNU. Today I will present the paper, MOOC Behavior Analysis and Academic Performance Prediction based on entropy. In this presentation, the paper will be divided into the four parts: background and methods and experiments and conclusion. Background. In recent years, MOOC has received a lot of attention, which has attracted millions of learners to accept in online education. However, low completion rate about 1 to 52% has become one of the main challenges in MOOC. However, therefore, how to improve the completion rate of the learners has become one of the research hotspots. Studies show that learners' behaviors can reflect their learning states and affect their academic performance. Therefore, how to correctly understand the learning states may become one of the ideas to solve the problem. In this paper, we summarize some typical behavior features to represent the learner's learning states and quantify the trends of the behavior by using an indicator to measure temporal behavior data. It's necessary to explore the internal association between them from a correlation analysis. In fact, different learning states represented by behavioral features can improve the effectiveness and interpretability of the academic performance prediction. Therefore, our methods include research context and feature extraction. In the research context, first we collect the data about the learners' online behavior from Xiaoliang X platform. 12 courses were selected as the research object. We initially obtained the behavior data by collecting and processing several log data and recorded information of the corresponding courses. These courses include 3 main activities: reviewing course reviews and submitting quizzes and discussing in the forum. Secondly, we decided two kinds of behavior features based on behavior data: statistical behavior features and temporal behavior features. Regarding to statistical behavior features, we can obtain them through the descriptive statistical results of the data, such as the frequency and average and variance, etc., which represent learners' general learning rules. About temporal behavior features, we used entropy as a main method of research to quantify the changes of the behaviors. About all experiments, our work is mainly divided into correlation analysis and academic performance prediction. In this section, we describe the relationships between the learner's behavioral features, entropy, and academic performance through the correlation analysis in 2 aspects. First, in the correlation analysis of the statistical behavior features and the corresponding entropy, we try to get an internal correlation between them. When the learners participate in different course activities, statistical behavior features obtained from the data can reflect their course engagement and learning styles. If the behaviors described by statistical features are closely related to entropy, both entropy and behaviors can reflect course engagement to a certain extent. In Figure 1, the results show that there is a certain correlation between each behavior feature and the corresponding behavior entropy, which indicates that the behavior entropy and the behavior are related, and some behavioral features are highly correlated. Secondly, it shows the relationships between the learner's behaviors and academic performance in the different courses through the correlation analysis between the behavioral features and the academic performance, and explore which behaviors are closely related to academic performance. The strong correlation between the features and the academic performance shows that specific behavior is closely related to academic performance. Experimental stage about the academic performance prediction is divided into 4 steps: feature selection and baselines and metrics and results. Feature selection is a process of selecting a subset of relevant features, because unnecessary features will affect the generalization ability of a model and increase its computational cost. So we use the correlation coefficients method to select the features for classification prediction. In order to explore the effectiveness of each feature on classification prediction and the probability of the model, we chose the 4 commonly used prediction models as the benchmark methods for learner performance prediction: logistic regression and the sport vector machine, the distinction tree, and the random forest, and use the features selected by above method as the input variables of the model for a predictive analysis metrics. In this study, we use the precision recall, F1 score, and the AUC as an evaluation metrics for the binary classification prediction. Results: in the analysis of the prediction performance of a model, random forest has the highest precision, F1 score, and the AUC in all courses, and the performance is best in general, while the sport vector machine performs best in recall, and the logistic regression has the weakest predictive performance. In general, each model has a good performance in prediction, which indicates that these models can identify important behavior features in the prediction process. We compare the results of the performance prediction of all courses with the partial experimental results of related research to verify the importance of different feature combinations related to learners in classification prediction. The priority results indicate that different feature combinations related to learners play an important role in classification prediction, and better datasets can also improve performance. Conclusion: in summary, the conclusion mainly includes: first, entropy can measure the behavior change of the learners in some aspects and reflect the course engagement, as well as some important behavior features. We propose a behavior trend indicator, entropy, based on exacting datasets. Then we conduct a correlation analysis between behavior features and the corresponding entropy and academic performance. The results shows that there is a correlation between entropy and corresponding behavior features. Thus, the trend of the behavior qualified by entropy can represent the behavior states of the learners to some degree. Secondly, the learning states represented by some statistical features are correlated with the academic performance, which can represent learners' engagement in a certain learning stage. Last, the effectively the effectiveness of the predictive features can explain the reason for the learner's course revision and provide accurate guidance for learners to learners academic early warming. In some interpretative prediction models, such as the random forest, some important prediction features can be found, which play an important role in predicting academic performance and provide suggestions for improving learning outcome. That's all. Thank you for your listening.